Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be talking about the book The Clean Coder by Uncle Bob C. Martin. If you guys remember last time, we talked about Chapter 6, which was all about practicing and the importance of practicing when we consider ourselves professional software developers, and how practice is key to making somebody a professional. We talked about the different ways you can do that with both just yourself and your partner and like a coworker or what have you. You could do a coding dojo, you can do coding katas, you can do wasas, and I explained all those in that video. So check that out if you want to know more about practicing. Today we are talking about Chapter 7, which is acceptance testing. Little bit different. This is what I discovered. Little bit different than just plain unit testing, which is kind of what I thought this was. But then after reading this chapter, I finally realized, oh yeah, I've done acceptance testing before. I just didn't realize it. So let's get things underway, and we'll go to the first slide. Really, acceptance testing is all about communicating the requirements between business and development team. Because there's a common disconnect a lot of times between those two groups. Business requirements are a common communication issue between programmers and the business. So oftentimes what ends up happening is that the business, they'll tell you what they need, and then programmers build what they describe, but sometimes didn't. So in delayed timelines, etc. So it's important to be able to communicate, hey, this is exactly what we want, and then, hey, this is exactly what we built for you. And Uncle Bob's going to talk about it in a passing, and then we can all agree that, okay, yes, this is an acceptable piece of work that then can release. So Uncle Bob talks about precision, and he talks about this death nail for both sides, which is premature precision, which is where you try to precisely articulate what exactly right in the beginning without ever having to know what to expect or without ever anything having even been built. Because what ends up happening oftentimes is that you start building something based on precise precision. That's kind of an oxymoron. Based on some very detailed, precise notes on how it should be built in the beginning. And then what often ends up happening is you have to tell the business team, hey, actually, that's not possible. I had to do this recently with a feature where we were trying to implement some stuff with dates and selecting specific times to filter out results. And then we had to just go to the business team and be like, hey, this is a lot more complicated than we initially anticipated. And then actually what ended up happening was in all things, there's this uncertainty principle. So things appear different on the drawing board than when they actually are implemented. So the more precise you make your requirements, the less relevant they become after implementation, because things change and sometimes things just aren't really possible. So you'd rather not spend that energy being super precise in the beginning, because it's oftentimes going to lead to changes a little bit later on. And, when you start to make all these predictions or precise arrangements or requirements, often you get estimation anxiety, which is estimates, which is, okay, no, this is something a little bit different. Estimates should be made on a low precision requirements. So opposite of premature precision is what Uncle Bob's kind of talking about here. You want estimates to be made on a low precision with the least amount of detail in the requirements, because estimates at the end of the day are just estimates. You shouldn't be getting anxiety about the estimates. So I think that's what he was saying in this section. because the requirements change all the time. So make the estimates as low precision, as less detailed as possible. Now, another, I guess, bad thing or downside here, we don't want late ambiguity, but we want to defer precision as long as possible in order to curb premature precision. So you want to delay the precision, just like you want to actually delay the acceptance tests until everything is like completely pretty much done. And Uncle Bob writes in his book, the solution to premature precision is to defer precision as long as possible. However, it can lead to late ambiguity. So yeah, that's kind of what I said earlier. We don't want late ambiguity, but we do want to push off precision. We do want to defer precision. Because what ends up happening if we have late ambiguity, this is where requirements are phrased in a certain way that just brings agreement, because things are already starting to get a little bit late on the schedule. So there's maybe a disagreement in the requirements. So you phrase a requirement in a certain way that brings an agreement, but it doesn't really solve the dispute. So what ends up happening is that it ends up being a bigger thing down the road. And yes, what he's saying here, you do want to defer precision as long as possible, but you still want to phrase the requirements a certain way that brings agreement amongst everybody. And at the end of the day, he says this is hard. Of stakeholders and programmers in order to define when a requirement is done. Now, there's different tests pass. The QA and the stakeholders have accepted. You are done. That is his definition of done. So when you're writing acceptance tests, you're essentially creating a suite of automated tests that, when passed, can mark the feature done. Hey, this feature that we just coded out does what the business wants it to do, and all the tests pass. This feature is done. It's accepted. It's ready to be merged in and deployed. And really, tests actually serve as documentation and not necessarily tests. They serve as documentation as to what your app should be doing, because they display, or rather test out functionality code, so kind of tests and be able to tell, these lines of this thing, right? So that's kind of the MO of these acceptance tests. They should communicate, they should be clear, and they should, it's a kind of high upfront cost, but then over the long term, the cost is small. To do is do one button click and all the tests run. Manual testing is another way to accomplish this. So you can manually test a feature branch, which is what we do at work too, but it can be costly because you have to wait for the feature branch to build. You have to wait for the QA to run through it. So if you're doing that for all your feature branches all the time, it becomes super costly. You need a ton of people to do it, and it costs a lot of time. But in the long run, automating these tests wins out. You should be having some sort of test suite. Like, I've used Cucumber in the past, and he listed out some other examples in the book, but Cucumber was the one that I was most familiar with, where you write tests in a given when and then scenario, and then you write the code to like execute those given when and thens. And I have an example a little bit later. So who should write acceptance tests and when? So QAs would collaborate to write the tests with the devs, and the devs would review them for consistency. If developers end up writing the acceptance test, they shouldn't be the same developer who wrote the feature. And I found this kind of interesting, and I don't know why. Well, I could kind of guess maybe why Uncle Bob says this is because if you completed your code in a very clean fashion, in a clean code fashion, then other people should be able to take a look at your code and be able to distinguish what it's supposed to be doing, and then they can write tests for it because the code is so cleanly written. They know what's going on. But to me, I would just have the same developer write the acceptance test because they know the code the best. It kind of makes sense that way. They write the unit tests anyway. It would make sense to, just write the acceptance test for it as well. And a couple other pointers when writing these tests. The business analysts, the business team, can write the happy path of the test because they would be most happiest if it all just works perfectly, right? They can write the happy path acceptance test. QA can write the unhappy path because they are normally supposed to find out bugs anyway, so they kind of know all the negative scenarios, the things that can go wrong. And again, this is kind of what I was saying a few slides ago. The acceptance test should be written as late as possible. Oftentimes, they should be written a few days before the feature is even implemented, and after the decision of what is going in the next sprint. Again, this is to kind of mitigate any last-minute changes, any last-minute deviations from what your original story expected. And that way, hey, nothing's going to pop up. These acceptance tests are exactly what we need. Nothing else is going to change. Boom, here they are. That's kind of what he means by they should be written as late as possible. And then by the midpoint of the iteration of the sprint, all tests should be ready. So you can write a few tests in the beginning, but then by the midpoint, all the tests should be ready to go by the midpoint of the iteration of the sprint. If you guys work in sprints of 2 weeks, that's what we do. We work in 2-week sprints. So you take a story, right? You take a story, you finish your coding part, then you start to write the acceptance tests. Or rather, this is when you're grooming a story, I think. You have a story to groom. You take it on. Before maybe the code is starting to be implemented, you write some acceptance tests. And then once we know what's going into the sprint, then you write more of the acceptance tests and you actually finish them. I think that's what he meant to say here, or that's kind of my interpretation of the timeline of when these acceptance tests should be written. So it's not, I don't think you do it, or you might still do it while coding is happening, but I think it's more so, okay, we have this story, it's not in our sprint yet. We're going to put a couple acceptance tests on there. Okay, now that we groomed it, we pulled it into the sprint. Okay, now let's finish the acceptance tests so that we all know what to expect of the story before any code implementation. The developer's role. So implementation work on a feature branch begins when the acceptance tests for that feature are ready. Okay, so this kind of lines up with what I was just saying on the last slide. Acceptance tests are in, they are put in the story, they are in Jira. Okay, now we start to work and code out the feature. And this is an example of some acceptance testing here, using a given when and then scenario. This is a very simple example. There's a lot of different testing frameworks like this. Again, the one that I'm most familiar with is Cucumber. But you have a scenario where you add 2 numbers. So given I have a calculator, when I add 2 and 3, the result should be 5. And then you can actually code this out in a test step class, annotated, if we're using Java in this example, annotated with a given when and then. You can see there you have addition going on, and then you have an assertion going on that it should equal 5. So this is I mean, it kind of does look like a unit test in a way, but it's just a split up unit test. You could easily write a unit test that has all of this within one test. But here it's splitting up into specific steps, specific acceptance criteria. Oh shoot, I'm sorry about that, guys. That was blocked off there. Oh, that wasn't blocked off when I put it like that. Oh, I'm sorry about that, guys. I forget even what this says. Connect the acceptance tests. Connect the acceptance tests. Let me see if I can find it in the book really quick. Because, yeah, there was something about connecting acceptance tests. The point of all of this is that the developer's job is to connect the acceptance tests to the system and then make those tests pass. Oh, okay. So if you have what you have on the left, right, that's written by the QAs, maybe the business team, it's your job to write what's on the right, I think is essentially what that's saying. Connect it to the system. Connect it to the app that you're working on. Next, test negotiation and passive aggressiveness. As a dev, you need to sometimes negotiate for a better test. This doesn't mean you just accept every acceptance criteria, because sometimes tests can be poorly written, they can make faulty assumptions, they can be too complicated. So if we looked at the previous example, if you got on the left, if you got something that said I add 2 and 3, then the result should be 6. Well, don't just write the acceptance test based on that. Go and talk to them and say, hey, actually, this isn't right. This is a faulty assumption. We need to rewrite this test. Negotiate for a better test is what Uncle Bob says, because oftentimes, again, they can make faulty assumptions. Tests can be written poorly. Tests can be too complicated, too. I've had that happen, where a test is just way too complicated. I'm like, okay, can we break this up a little bit? Acceptance tests and unit tests is kind of what I alluded to earlier. They are not the same thing. However, you can view both of them as documentation on how your app works, but they serve different purposes. So unit tests are written by devs for devs. They are specific functions. They're specific tests that test specific functions and lines of code. They are different from acceptance tests, which are written by the business for the business. The business team will be looking at these. Even if the dev ends up writing them, the business pays attention to these because they test system-wide features. They test everything working together, not just specific lines of code. And this can be both at the API and the UI level. But Uncle Bob has a section here where he says the GUI is hard to test. It can be hard to write acceptance tests for the GUI, again, because things change in the GUI so much. I mean, how oftentimes maybe in development you move a button around because it's more, you're trying to find the most appealing location for the button. So if you try to write a test that clicks on a specific location and the button ends up not being there, well, the test is going to be flaky. It's not going to pass all the time. So Uncle Bob advocates for this single responsibility principle. We've talked about this in his other book, where he basically says in your test, you should separate things that change for different reasons, and you should group things that change for the same reason. Essentially, you want to make your tests not breakable even when changes happen. So oftentimes you want to treat the GUI as an API rather than buttons, sliders, grids, menus, divs, tables, all that stuff. Like I said earlier, you don't want to click on the button at the certain location, X and Y coordinate, but maybe you want to click on it based on its name or its ID or its class name, things that aren't really going to change. The location will change, but maybe the name of the button's not going to change. So you can test it that way, and you can test the response from clicking on the button. maybe when you click on the button, it calls an API, and you can mock that API call and ensure that things are being returned in the result that you want them to be returned. And next, he talks about testing through the right interface. So writing tests that test the feature of the system underneath through the GUI. So again, this is kind of what I was saying in the last slide. You should want to test the underlying functionality of that button click, not necessarily finding and clicking on the button. Because again, the GUI can change. They can cause a lot of different rewrites of your test. And that could lead to some frustration. You can then maybe have to rewrite a ton of tests when the GUI's change. I know I've had that happen before. Or you will stop changing the GUI because, this just causes too many issues in acceptance testing. Either one is not a very good option. You want to be able to adapt and change your app, but you want to do it in a very efficient way and make everything decoupled so you don't have to change a ton of different things. So you separate the GUI from the business rules and only test the business rules. And this is one way to do this. You can use mocks and stubs to achieve this. So mocks, like in Java, you can use Makito. It's a library. You can see it there in this coding example, where you create a mock object that simulates the behavior of a real object. So you can see this with early up here on this coding example. This is annotated with app mock so that you know this is a mock object. And then you can use this mock object to simulate behavior of what the real mock object should do. So this dependency, we're using it to create this my class. This is a dependency within my class, and then we're using my class to run a certain method that uses that dependency. And then we can verify things and assert things based on the actions of that. So you can use mocks, you can use stubs. Stubs are basically the given, when, and then statements. You can create stub objects that provide, and again, I'm sorry, I don't know why that covers up there. I'm going to have to do a better job of that, guys. I'm sorry. I'll have to use the toContent slide type and not try to do this again. But essentially, stub objects provide pre-configured responses when those methods are executed. So this is this line. I'm sorry, I can't highlight that, but it's the when and then steps. You can use this in Makito by saying Makito.when. So Makito.when dependency.do something is called result. So then when you call this, because again, this dependency.do something is within my class. It's within the myClass.process method. So you're not going to actually call it. You're going to call myClass.process. And then by calling that, dependency.do something is going to run. And you're going to stub it out by saying, when it runs, it should return stub result based on the conditions or maybe the arguments that you pass in a process. And it's not taking any arguments right now, so this should just return stub result. So then you should be able to see and assert that stub result is returned. All right, last slide, guys. A continuous integration system. These are like, Jenkins is a very popular continuous integration system. Your test should be run several times a day in a continuous integration system. This goes for the acceptance tests, unit tests, what have you. So every time you commit and push something to your version control, to GitHub, the CI system kicks off. And it kicks off with a certain build. It'll tell you the commits that happened that triggered the build. It'll have your specific feature branch that you're working on. It should do this, and it should spit out some results and analyze the build for any failures or passing tests. This is key because it should run several times a day. And if something fails, you should investigate it right away because everything should pass. That's essentially why this should run several times a day. Because if you think about it, everybody's pushing up code, working on stuff. You want to make sure that even with all those changes, things are still passing. And if something does fail, you should investigate it. You should investigate it right away. A broken build in a CI system should be an emergency situation, says Uncle Bob. And failing tests are a sign that bugs have been introduced into the system. So, in conclusion, it's very easy to assume the business team and the development team are on the same page. But acceptance tests are the only way to effectively communicate and ensure that the business team and development team are on the same page. Using acceptance tests, you can effectively communicate design and feature changes in an application between stakeholders and devs. And that's really the key and really the crux of this whole chapter. How do you communicate between stakeholders and devs? You write acceptance tests. You write them together. You write them as late as possible to avoid any premature precision, but you don't want late ambiguity. And then you make sure that they pass. And with that, that's going to do it, guys. Thank you very much for listening. About halfway through this book. So making progress. Thank you for sticking with me during this journey. And we'll be back on next time. My name is Chris. This has been Chee-Tash. Take care, everybody.